Today we're going to be going over the second part of 8.1. So with this part, we are working on the absolute value inequalities. So if you remember from the first part, we did absolute value equations. Today we're going to be working with inequalities. We're going to be doing the same exact thing. However, when you change that sign on one part of your inequality, you're going to be changing the inequality sign as well. So you're just flipping that just like you would if you were multiplying or dividing each side of the inequality by a negative. So if we look at the first example, again, we want to isolate that absolute value. If we see that the absolute value is isolated, we ask ourselves, is it possible for the absolute value of that number to be less than the number that's on the other side, greater than the number on the other side, and less than or equal to or greater than or equal to? So for example 1, it's giving us the absolute value of x minus 5 is less than 2. So ask yourself, is it possible for the absolute value of something to be less than 2? Yes, it is. So separate this into two inequalities without the absolute value bars. So this is going to turn into x minus 5. We're going to switch the sign and switch the sign on the 2 to be negative 2, as well as x minus 5 is less than positive 2. We're going to solve both of these just by adding that 5 to each side. So we have x is greater than 3. Do it to the other one as well. X is less than 7. Look at these two inequalities. You are writing this using interval notation, so look at the way these inequalities are with the numbers as well as the signs are pointed to. The inequality on the left has a smaller number, so your signs point in to each other. So this is an and statement, which means the only thing you need are the two numbers separated by a comma, and then look at those signs. They're not equal to, so both get a set of parentheses. For number 2, we have the absolute value of x is less than or equal to 5. The absolute value is isolated. Ask yourself, is it possible for the absolute value of something to be less than or equal to 5? Yes, it is, so separate it into 2. Get rid of the absolute value bars. We're going to have x is greater than or equal to negative 5, and x is less than or equal to positive 5. Both of these have the x that is isolated or by itself already, so look at your signs. They point in towards each other, so this is an and statement. So we're just going to have that negative 5, that positive 5, and because they're both equal to one another, they have those brackets. For the other number 2, we have the absolute value of 2x is less than or equal to 20. It is possible for the absolute value of something to be less than or equal to 20, so we're going to separate this into 2. We're going to have 2x is greater than or equal to negative 20, as well as 2x is less than or equal to positive 20. We're going to divide each side by that 2 on both of these, so x is going to be greater than or equal to negative 10, as well as x is less than or equal to positive 10. Our inequality on the left includes the smaller number. Those signs go in towards each other, so this is an and statement, so we're just going to have the negative 10, the positive 10, separate them with commas, and both get the brackets since they're also equal to the negative 10 and the 10. For number 3, we have the absolute value of 2x is greater than 7. So is it possible for the absolute value of that 2x to be greater than 7? Yes, separated into 2. So 2x is less than negative 7, as well as 2x is greater than positive 7. We divide each side by that 2 on both of these, and we get that x is less than negative 7 over 2, as well as x is greater than positive 7 over 2. These two inequality signs point away from each other, so this is an or statement, which just means that you're going to go from negative infinity up to negative 7 over 2. Doesn't include the negative 7 over 2. And this is going to be a union with the positive 7 over 2 to positive infinity. And then remember, both of these 7 over 2 and the negative 7 over 2 get the parentheses on them because it's not also equal to. For your next example, you have the absolute value of x minus 4 is less than or equal to 10. It is possible for the absolute value of something to be less than or equal to 10. So we're going to separate this into x minus 4 is greater than or equal to negative 10, and x minus 4 is less than or equal to positive 10. We add that 4 to both sides for both of these. We have x is greater than or equal to negative 6, as well as x is less than or equal to 14. That inequality on the left includes a smaller number. Your signs point towards each other, so it is an and statement. So it's just going to be a bracket, negative 6, comma 14 with a closed bracket. For number 5, we have the absolute value of x minus 3 is greater than 9. So we're going to separate this into two. We have x minus 3 is less than negative 9, as well as x minus 3 is greater than 9. We're going to add the 3 to both sides for both of these. So this is going to give us x is less than negative 6, as well as x is greater than 12. We look at these two inequalities. The one on the left includes a smaller number. Those signs point away from each other. So this is an or statement. So we're going to have the negative infinity to negative 6 with parentheses on both, with a union of 12 to positive infinity. Parentheses on both of those as well. For 6, we have the absolute value of x plus 1 is greater than or equal to 1. We can separate this into x plus 1 is less than or equal to negative 1, as well as x plus 1 is greater than or equal to positive 1. We subtract that 1 from each side to get x is less than or equal to negative 2, as well as x is greater than or equal to 0. Those two signs point away from each other. So again, we have an or statement. So we're going to have from negative infinity up to negative 2, including the 2, with a union of 0, including the 0, to positive infinity. For 7, we have the absolute value of 2x plus 1 is greater than or equal to 3. We're separating this into 2. So 2x plus 1 is less than or equal to negative 3. 2x plus 1 is greater than or equal to positive 3. We subtract the 1 from each side, so 2x is less than or equal to negative 4. Then we divide each side by the 2 to get x is less than or equal to negative 2. For the other one, we're going to subtract the 1 from each side to get 2x is greater than or equal to positive 2. And then we divide each side by the 2 to get x is greater than or equal to 1. We check those inequalities. The one on the left includes a smaller number. Those signs point away from each other. So this is an or statement. So it's just going to be from negative infinity up to negative 2, including the negative 2, with a union of 1, including the 1, to positive infinity. For 8, we have the absolute value of 5x minus 2 is less than 6. So again, we're going to separate this into 5x minus 2 is greater than negative 6, as well as 5x minus 2 is less than positive 6. Working with the one on the left first, I'm going to add that 2 to both sides. I get 5x is greater than negative 4. Then I divide each side by that 5. And I have x is greater than negative 4/5. For the one on the right, I add the 2 to both sides. So I get 5x is less than 8. I then divide each side by the 5 and have x is less than 8/5. My inequality on the left includes a smaller number since it is negative and the other is positive. Those two signs are pointing in towards each other, so this is an and statement. So I'm only going to have that negative 4/5, comma 8/5, and I'm going to put parentheses on both since they're not equal to. For 9, we have 4 times the absolute value of x plus 2 minus 3 is less than 13. Our absolute value here is not isolated, so that's where we first want to start with. So we're going to undo the addition or subtraction before we undo the multiplication or division. So we're first going to add the 3 to both sides. This is giving us 4 times the absolute value of x plus 2 is less than 16. Divide each side by that 4. So we just have the absolute value of x plus 2 is less than 4. Your absolute value is isolated. Ask yourself if it's possible. In this case, yes it is. So separated into x plus 2 is greater than negative 4, as well as x plus 2 is less than positive 4. We subtract the 2 from each side for both of these. So this is going to leave us with x is greater than negative 6, as well as x is less than 2. Those two inequality signs point in towards each other when the inequality on the left has a smaller number. So this is an and statement. So our answer is just going to have the negative 6 and the 2 with parentheses around it since they're not equal to. For 10, we have 8 minus the absolute value of 2x minus 1 is greater than or equal to 6. Again, we have to isolate that absolute value first. So we're going to start by subtracting the 8 from each side. We get a negative, or the opposite of the absolute value of 2x minus 1 is greater than or equal to negative 2. From here, we're going to divide each side by that negative 1. We flip the inequality sign. So this is giving us the absolute value of 2x minus 1 is less than or equal to positive 2. This is possible, once again, so we separate this into two inequalities. So 2x minus 1 is greater than or equal to negative 2, as well as 2x minus 1 is less than or equal to positive 2. To start off with the 1 on the left, we're going to add the 1 to both sides. So we get 2x is greater than or equal to negative 1. And then we divide each side by that 2 and have x is greater than or equal to negative 1/2. For the one on the right, I'm going to add the 1 to both sides. So I get 2x is less than or equal to 3. And then I divide each side by the 2, and I have x is less than or equal to 3 over 2. The inequality on the left includes a smaller number. Those signs point in towards each other, so this is an and statement. We're equal to as well, so we're going to have brackets on the negative 1/2, comma 3 over 2, close brackets. For 11, we have 7 times the absolute value of x plus 2 plus 5 is greater than 4. So for this one, again, we're going to undo that addition first. So we're going to subtract 5 from each side. We get 7 times the absolute value of x plus 2 is greater than negative 1. From here, we're dividing each side by that 7. So we're left with the absolute value of x plus 2 is greater than negative 1/7. Ask yourself if this is possible. The absolute value of anything is a positive number. So is it possible for a positive number to be greater than negative 1/7? It's always possible. So since it's always true or always possible, we have infinitely many solutions or just all real numbers. So you can give me that double-backed R for all real numbers. Last example we're going to work through is this number 14. So we have 1 over the absolute value of 2x minus 3 is less than or equal to 5. So for this one, we're going to treat this like an equation and just multiply each side by that absolute value of 2x minus 3 to get it off or away from that denominator. So we're going to have 1 is less than or equal to 5 times the absolute value of 2x minus 3. We're going to divide each side by that 5 so that way we can isolate that absolute value. So it's just 1/5 is less than or equal to the absolute value of 2x minus 3. Now if you want to rewrite this to where that absolute value comes first, you can. So we're just going to have the absolute value of 2x minus 3 is greater than or equal to 1/5. We're going to separate this into two inequalities. So we're going to have 2x minus 3 is less than or equal to negative 1/5, as well as 2x minus 3 is greater than or equal to positive 1/5. I'm going to move 3 over on both of these by adding it to both sides. When I do that, I want a like denominator of that 5. So I'm going to I'm going to add 15 over 5 to that one side with that 1/5. So these 3's cancel out, so we're going to have 2x is less than or equal to 14 over 5, as well as 2x is greater than or equal to 16 over 5. I'm going to multiply each side by the reciprocal of that 2, so I'm dividing each side by 2, which just means that I'm going to multiply that 14 over 5 times 1 over 2. as well as that 16 over 5 by 1 over 2. So this is going to leave me with the 14 becomes a 7, 2 becomes a 1, 7 times 1 is 7 over 5. So x is less than or equal to 7 over 5, as well as the 16 becomes an 8, 2 becomes a 1, so x is greater than or equal to 8 over 5. The 7 over 5 is less than the 8 over 5. Those signs go away from each other, so this is an or statement. So we're just going to have that negative infinity up to 7 over 5, including the 7 over 5, with a union of 8 over 5 to positive infinity, including the 8 over 5.